Welcome to the video lesson for section 6.4, dot product. Let's get started. The dot product of two vectors will always yield a scalar number, not another vector. So when you've done the dot product successfully, you get an integer value or sometimes a fraction. Our formula for two vectors u and v is going to be u dot v is equal to u1 times v1 plus u2 times v2. So we're multiplying corresponding components here. Again, you can see we're multiplying the x components together and also the y components together. And this looks like multiplication, but there is no actual multiplication of vectors, so it's always going to simplify the dot product of two vectors. As an example of the dot product, we have two vectors here, v and u. We want to find the dot product for them. So we're going to take our corresponding components. I'll take my two x components and multiply them, and then also take my two y components and multiply them. So you can see that we have 4 times 2 plus 5 times 3, and then when we simplify that, we get 23. And again, 23 is a scalar value. It is not a vector. For our second example, again, we have two more vectors, u and v. We're going to multiply corresponding components. So I can multiply my x components together, and I can also multiply my y components together. So you can see here that we have multiplied those together, and when you simplify your final answer, you get a scalar value of 0. We have a couple properties for our dot product. So we have the dot product of u and v is going to be the same as the dot product of v and u. So the order of the vectors doesn't matter. The dot product of 0 and any vector is always going to be 0. If I were to add two vectors together and then take the dot product with another vector, it's the same as taking the dot product of that vector with the two vectors separately and then adding them together. A very important property here, the dot product of a vector and itself is equal to the square of its magnitude. We're going to be using that in the future. And then finally, if I have a scalar number times a dot product, I can multiply the scalar number by one of the vectors and then do the dot product. So I could do the scalar number times u and then do the dot product, or the scalar number times v and then do the dot product. For our example here, we have the dot product of u and v, and then we're multiplying that by this vector w. So I'm going to go ahead and do the dot product of u and v first. And you can see that I have, again, corresponding components being multiplied together, and then I'm adding the other set. And I got negative 14 as my scalar. I'm then going to take that scalar number, and I'm going to go ahead and I'm going to multiply that by my vector w. And my final answer, because I have a scalar times a vector, is a vector. And I have negative 14, positive 28 as my final answer. For our next example, I have u dot 3 times v. And I'm going to go ahead and rewrite that as 3 times the dot product of u and v, mostly because I've already done that. So we can see from our last example, we still have the same scalar of negative 14. But now I can take that number and I multiply it by my scalar of 3. And then when I'm done, I end up getting negative 42 as my final answer. For orthogonal vectors, two vectors are in fact orthogonal, which is very similar to being perpendicular, if they meet at a right angle. And we can identify two orthogonal vectors if the dot product is 0, so we see that u dot v would be 0. For our example here, we're going to try and determine if we have orthogonal, parallel, or neither for our vectors. We talked a little bit about parallel. Basically, one vector is a scalar multiple of the other one, and this was talked about in the last video. Let's go ahead and start with our dot product. So if I want to do u dot v, then I'm going to get 15 times negative 5, and then plus 45 times negative 15. We end up getting negative 750. So these are definitely not orthogonal because the dot product was not 0. So the next step then is to see, can I write one of these vectors as a scalar multiple of the other one? And an easy way to do that is I can take two components and possibly divide them to see what I get. So let's say that I did let's do u1 divided by v1. That's 15 divided by negative 5, and I get negative 3. If that same scalar holds up for the other components, then we definitely have parallel vectors. So I can do u2 divided by v2, which would be 45 divided by negative 15. And again, we see that we get negative 3. So what this means is negative 3 times v is going to equal vector u. So we definitely have parallel vectors because one of them is a scalar multiple of the other one. All right, we're going to try that one more time. We have two vectors u and v. We want to see if they are orthogonal, parallel, or neither. So to begin with, let's go with the orthogonal part. We're going to do the dot product of u and v. So we have 2 times 6, and then minus 3 times 4. which is going to be 12 minus 12, getting us a value of 0. Since the dot product does in fact equal 0, we can say for sure that our vectors are orthogonal. Finding the length of the vector, just to review, the length of the vector is also called the magnitude, and notice we have a notation here to signify the magnitude of v. I mentioned this a little bit before in our properties, but a separate way to find the magnitude is related to the dot product, because the dot product of two vectors is equal to the magnitude squared. So if I want to solve this expression for my magnitude, what I can then do is I can go ahead and take the square root of my dot product, and that would be an alternate way to go ahead and find my magnitude. We're going to go ahead and try and use the dot product to help us find the magnitude of a vector. Again, to do that, we're going to take the dot product of the vector and itself. So you can see for our first example here, if I did a dot product of u and u, then I'm going to get -1 times -1, and then plus 3 times 3. And then when I simplify things, I end up getting radical 10. Doing the same thing for my next vector, again, we're going to do the dot product of v with itself. So you can see that I have 2 times 2, and then plus -4 times 4. When I simplify that, I get radical 20, and then I can simplify radical 20 to end up being the 2 times the square root of 5. For the angle between two vectors, when you have two non-zero vectors, you can find the angle between them by using the following formula. We have the cosine of theta is equal to the dot product of u and v divided by the magnitude of u times the magnitude of v. The one thing to note here is the last step is going to be taking the cosine inverse of whatever your fraction is right here to finish solving for your angle. All right, using the vectors from our last example, we're going to go ahead and find the angle between them. So just to reiterate what our formula is, we have cosine of theta is equal to u dot v divided by the magnitude of u times the magnitude of v. I already know what the magnitude of u and v are. I found them in my last example. So I have square root of 10 over the square root of 20. I now just have to find the dot product. So we have -1 times 2 plus 3 times -4, which is going to be -2 plus -12 or -14 over radical 10 times radical 20. To finish solving for my angle, I'm going to take the cosine inverse of that. So I have theta is equal to the cosine inverse of -14 over radical 10 times radical 20. And I want to put that in as exactly like that in my calculator so I don't have to do too much rounding. And I end up getting 171.87 approximately as my angle. We're going to end our lesson with one more example of finding the angle between two vectors. So again, our formula, cosine of theta is equal to u dot v divided by the magnitude of u times the magnitude of v. If I go ahead and find my dot product, it's going to be 4 times 3 plus 3 times 5. And then for my magnitude of u, I get the square root of 25. For the magnitude of v, I get the square root of 34. I'm going to go ahead and simplify my numerator. So we get 27 divided by the square root of 25 times the square root of 34. And then my last step to finish solving for my angle is to take the cosine inverse of that. And we have 27 over radical 25 times radical 34. And we end up getting approximately 22.17 as our angle. All right, guys, that does it for notes for this section. Go ahead and get started on the homework, and good luck.